Okay, I've got another question here about variable acceleration. We've been given the acceleration and it's in terms of t, and we've been asked questions about the velocity of this vehicle. Now, to get from acceleration to velocity, we're going to have to integrate. Now, I know SUVAT does not apply in this case, but the word SUVAT can actually act as a guide to whether you should be integrating or differentiating in these sort of questions. If I write down SUVAT vertically, and the only thing you have to remember is down for differentiation, which means if you've got an expression in displacement, you differentiate to get a velocity and you differentiate again to get an acceleration. Of course, the reverse is true, and therefore if you're given an acceleration and you need to get to the displacement, you need to integrate twice. In this case, we've been given an acceleration. And part A, we've been asked to find the speed of the car in kilometers per hour in terms of t. Okay, I've written down the acceleration. And from my SUVAT ladder, here's acceleration. I need to climb up the ladder to velocity. I need to integrate. So the velocity is equal to the integral of the acceleration with respect to time. And this is equal to the integral of 180 minus 360 t dt. And this is going to equal 180 integrated is 180t minus a half multiplied by 360 t squared. Just to check, differentiate this. The 2 comes down, cancels with the other 2. That just leaves 360, and the power of t drops down by 1, back down to t. Unfortunately, we have to add a constant of integration, so I have to write plus c at the end of it. Now, clearly, I want to find the value of this constant of integration, and luckily, in the question, it says starting from rest. What that means is that at t equals 0, v equals 0. So if you look at our expression, t is equal to 0, well, both this term and this term will go to 0. And as our velocity has to equal 0, it means that c must equal 0. So I can write our expression for velocity is equal to 180 t minus 180 t squared, which if we take out 180 t as a factor is 1 minus t. And that will be the answer to part A. Okay, let's have a look at part B. The speed limit is 40 kilometers per hour. So what the question is asking us to do is, and I'm going to use this version of my answer because we're going to be solving a quadratic inequality. What the question's asking us to do is to find out when 180 t minus 180 t squared is greater than 40. Before I do anything, I can cancel a 10 throughout the equation. And the best way to think about it is just think about what the shape of this quadratic will be. We've got a negative term in front of the t squared. So this is going to be some sort of N shape. I've got no idea where it is on the axis at the moment, but you can roughly see what might be going on is that if this was 40, you can clearly see that if that was T1 and that was T2, it would be between these 2 times that the car would be speeding. Now, when I'm dealing with this in GCSE, I always tell my students to get rid of this inequality by saying at the critical points, the inequality turns into an equal sign because we need to know where these goalposts are. So at the critical points, I'm also going to take a factor of 2 away from this equation by halving all of our terms. So I get 9t minus 9t squared is equal to 2. Now I'm going to put everything on the left-hand side, probably turn everything positive to make this term positive, just makes the maths a little bit easier, and equal to 0 on the right-hand side. So therefore, 9t squared minus 9t plus 2 is equal to 0. Now, this is in the middle of a mechanics paper. It's only 4 marks, and there is a good chance this will factorise simply. Let's have a guess. I reckon that's going to be 3t and 3t. Now, if I put a 2 there and a 1 there, these are both have to be negative because I'm going to have to create positive 2. I get a 3t here and a 6t here. So yes, it does work out. You can use your calculator or you can use the quadratic formula, but here we have a perfectly good answer. If that is true, either that must equal 0 or that must equal 0. So therefore, t is equal to a third, or t is equal to 2/3. Now t is in hours, so this is a third of an hour, and that's 2/3 of an hour. Converting it to minutes, a third of an hour is 20 minutes and 40 minutes. Now, given that a speed limit, if you're sitting at 40, you're still okay. So the car is speeding when t is greater than 20 and t is less than 40 minutes. So when it's equal to 20 minutes, the car is at that precise moment doing 40. It has to be above 20 minutes and below 40. And that is the answer to part B. Now in part C, if we're to find the average speed of the car, we need to find the total displacement or distance this car travels. So we're going to have to integrate again. We're going to have to integrate the velocity again and climb the Suvat ladder to get to displacement. We then have to put in t is equal to 1 hour. And that will be the displacement after an hour. So let's have a go. So if this is the velocity here, I can say that s is equal to the integral of v dt, and that is equal to the integral of 180 t minus 180 t squared dt. Again, with a lot of integrals, it's good to take the 180 out as a factor and just integrate. The integral of t will become a half t squared, and the integral of t squared will be minus a third t cubed plus k. I've used c already. The values are not necessarily the same, but straight away, if we're talking about starting from rest, it's starting from the origin, and therefore we can assume if it is starting from the origin when t is equal to 0, the displacement we want to be 0. So yet again, the same argument applies. This term is 0, and this term is 0, which means k will be 0. So I can get rid of k. So s, when t equals 1, is equal to 180. This will be a half minus a third. So putting these two in a common denominator, I get 180. And this is equal to 180 multiplied by 1 over 6. And this is equal to 30 kilometers. Now, as the car is only traveling for 1 hour, and the distance it covers after that first hour is 30 kilometers, the average speed equals 30 kilometers per hour. And that is the answer. There you have it.